Hello everyone. In this video, we will talk about measurements and dimensional analysis. First off, measurement I think is a quite common notion that many of you have already known. Maybe you can have velocity, which is kilometer per hour, or maybe time, which is minutes, hours, second, and temperature, which can be um, Celsius, Kelvin, and many more. But if you notice, there are a lot of units. So what should we use? Which one of them should we use? And so that's why we have the SI units. This is an universal system that most countries use in maybe their papers or anything that require unit. So you can search for the full list in maybe on the internet, but here we have the most commonly used ones, which are mass. Uh, so it's kilograms, second for ton, meter for length, Kelvin for temperature, ampere for current, mole for the amount of substance, and candela for luminous intensity. Moving to dimensional analysis, we will first look at dimensions, which is how we present some physical quantities. For example, here I have length, mass, and time. And as you can see, word, I put a letter inside a box. And so if you want to write the dimension of maybe velocity, it can be L over T, right? So maybe um, force, which is F equal ma. So it will be L over T squared times mass, right? This acceleration, this mass. But how do we actually apply this to solving problems? Well, to do this, we will have to know how can an equation be meaningful. If we have A plus B equals CD, maybe over E2, for this equation to be meaningful, the dimension of this side must be equal to the dimension of this side. And what I mean here is that dimension of A equal to the dimension of B. And this can also be true if this is a minus. Um, but when with this side, we will have dimension of C times the dimension of D over the dimension of E. So looking at this, you can um, understand how this calculation works. And now I will give you a more specific example for this. Now let's say I cannot remember V equal A times T power to the what? Power to what? So this velocity, acceleration, and time, right? And so um, this should be physically correct, right? So the dimensions of this and this should be the same. So let's see, we have V, which obviously is L over T, right? But now A times T power X, we will have acceleration first, which is L over T squared, right? But this one is t distance x here n equal to L over um, t to x, right? So we'll have this one is 1, right? L the same, so this one must be the same as time here too. We have 1 or equal to 2 minus x and x equal 1. And you will know that v equal at, and this is correct. This is just an example. To if you want to see more examples where I use this to solve problems, you can watch the next video after this.